Let's see how to differentiate y equals 2x sine x divided by x squared plus 1. Please note that the 2 right here is a constant. Using the second property of differentiation, that constant can be factored out, and we can simply differentiate the rest of this function, this highlighted part alone. Therefore, let me write dy by dx as 2 times the derivative of this part. However, when you differentiate that remaining component, you have to apply the quotient rule, because this part right here is a quotient. So what's a quotient rule? If you have two functions, f and g, which are in the form f over g, they both are functions of x. Let's say we need to differentiate this quotient, f over g prime. We know that this is going to be equal to g times f prime minus g prime f. All of that's divided by g squared, where g prime and f prime are the first derivatives of g and f respectively. So if you can remember that, this question cannot be difficult. What I'm going to do next is I'm going to label this numerator, this part without the 2, that part as my f. The denominator will be labeled as my g. Of course, g prime is very straightforward. It is very simple. G prime is equal to 2x. If you differentiate x squared plus 1, g prime is going to be equal to 2x. The challenge is to find f prime, because your f is equal to x times sine x. What should be f prime? F prime, or the first derivative of f, should be the differentiation of this part, which is a product of two functions of x. Neither of them is a constant. So there's nothing that can be factored out, which means when you differentiate that f, you have to use the product rule. So what's the product rule? The product rule also was introduced using f and g, but I'm not going to use f and g because I have already used f and g in this explanation. So let me write down the product rule using two other symbols. Let's say h times k. H times k, where h and k are functions of x. Let's say I need to differentiate this guy, prime. This is going to be equal to h times k prime plus h prime times k. If you cannot remember the product rule, you have to go back and watch that video. Then using that result, I can differentiate the function f right here. First of all, I have to label one of them as h, the other one as k. So let me label the x right here as my function h, the sine x right here as my function k. Then using those two things, I can easily write down f prime. What should be your f prime? F prime should be equal to, look at this result, the right hand side, and I'm going to apply it as it is. H times k prime. H is equal to x. K prime. K is equal to sine x. K prime is the derivative of sine x, which is equal to cosine x. That plus h prime. Since h is equal to x, the first derivative of h should be equal to 1. That times k. K is sine x. 1 times sine x is equal to just sine x. So that's your f prime. All right. Now we have g prime and also f prime. Now I need to look at this right hand side of that equation and fill all of that in this space right here. Let me do that. G times f prime, that is this first term on the numerator. G is equal to x squared plus 1. That times f prime. F prime we calculated right here, which is equal to x cosine x plus sine x. Let me write it inside parentheses. X cosine x plus sine x. And then I have this negative symbol. Let me write that down. G prime times f. G prime is equal to 2x times f. F is right here we have x times sine x. That's the definition of f. And all of that should be divided by g squared. G is equal to x squared plus 1, that squared. Now you may simplify it some more and keep it as a nicer answer. Dy by dx should be equal to, there's this 2 still outside. I will open the big brackets. When I multiply each of these two terms with the first term x squared right here, it's going to be x cubed times cosine x. Then x squared should be multiplied by the sine x. Then we have a plus x squared sine x. And then I need to multiply both of these terms by 1. When I do that, I will have a plus x cosine x and a plus sine x. So I'm done with this first part, and then I have a minus 2x times x sine x. So it's a minus 2x times x sine x is equal to 2x squared sine x. That's the complete numerator. All of that has to be divided by x squared plus 1, everything squared. Now if you simplify that numerator, we can see some like terms exist. Dy by dx should be equal to 2 times, let me open the big brackets, only x cubed term is this one, so I'm going to write it as it is. Let me just highlight that one to say that I have addressed that term, x cubed cosine x. And then I can simplify x squared sine x, which is a positive term, and minus 2x squared sine x. When I simplify those two terms, it becomes a negative x squared sine x. So I'm done with those two terms as well. We have negative x squared sine x. And finally, I have these two terms remaining. Let me just go ahead and write those two terms down. Plus x cosine x plus sine x. All of that must be divided by x squared plus 1, everything squared. I think what you need is a revisiting of the quotient rule and the product rule. If there's anything not so clear in this problem, please feel free to let me know. Thanks.